Good morning, students. Today's topic is sensible heating. So objective of the sensible heating is sensible heating. It is very much important process for psychrometric is concerned. So sensible heating objective is we need to increase the temperature of the air. We need to increase the temperature of the air without increasing the moisture content. Okay, that is the main objective of sensible heating. So to explain the sensible heating, we need to have some illustration. We have a duct, through this we are sending air. In between we have placed the heating coil. Okay, so through this heating coil we are sending the hot fluid in, and it will be coming out with the hot fluid out. Okay, right. So inlet air temperature is TDP1. At inlet we have marked TDP1, triable temperature at 0.1. So outlet temperature of the air TDP2. Okay, at 0.2 TDP2. So TDP2 temperature is always higher than that of TDP1. Why? Because this air is absorbed heat from the heating coil. Okay, so the temperature of the outlet air is higher than that of your TDP1, inlet air temperature. Now we want to compare these all three temperatures, TDP1, TDP2 and TDP3. TDP3 is higher than that of remaining two. Okay, so we can write the comparison statement. TDP3 is greater than TDP2 is greater than TDP1. Why? Because the heating coil is applying heat, so it is maintaining higher temperature than that of your TDP1 and TDP2. Okay, right. TDP2 is, why TDP2 is not more than TDP3? Because some of the air is bypassed, not passing over the or touching over the heating coil, so the temperature TDP2 is lesser than that of your TDP3. Okay, right. Here lot of parameters are there. TDP1, temperature of air at inlet, triable temperature of air at inlet. TDP2, temperature of air at outlet. TDP3, temperature of air heating coil. So these TDP1, TDP2, TDP3 we are going to mark in a psychrometric chart. This horizontal line represents your triable temperature. So triable temperature can be measured with the help of normal thermometer. And vertical axis represents specific humidity. It can be denoted as omega. The unit of the specific humidity is kg by kg of dry steam. What does it mean? 1 kg of dry steam, how much amount of moisture content is available will give you the specific humidity. Okay, right. So our aim is to maintain the specific humidity constant while increasing the temperature of the dry air. Just now we are going to mark 0.1 with the help of your triable temperature 1. Okay, so if you want to mark a point in a psychrometric chart, we need to have two parameters minimum. So one is triable temperature. We need to have one more parameter. Let us assume that wet bulb temperature. This curved line will give you the wet bulb temperature. How to measure the wet bulb temperature? The thermometer, normal thermometer, the bulb is wounded with a wet cloth. So if you measure those conditions, that will give you the wet bulb temperature. Okay, if you assume the wet bulb temperature for condition 1, so draw a inclined line. From horizontal line we can draw a vertical line, where it will intersect we can mark the 0.1. Okay, so this is how we can obtain 0.1. So our objective is need to maintain constant specific heat, so we can draw a horizontal line, so omega 1 is equal to omega 2 by maintaining omega 1 equal to omega 2. So now we are coming to your 0.2. We have only data triable temperature 2. If you draw a vertical line from the triable temperature 2 up to this horizontal line, constant specific humidity line, so here the intersection point we can mark 0.2. Okay, right. So TDP1 corresponding to the TDP1 we have marked 0.1, corresponding to TDP2 we have marked 0.2. Okay, then according to this comparison statement, TDP3 is always higher. Okay, heating coil temperature is always higher than that of air inlet as well as air outlet. This point is marked just far away from 0.1, because this in the horizontal axis dial temperature is increasing from left to right. So, we have marked 0.3 far away from this 0.1. Okay. Now, we need to calculate how much amount of heat added into the air for sensible heating purpose. Okay. With the help of standard equation, Q is equal to m dot into Cp into delta T. Q means heat added or heat content. So, m dot Cp into delta T, m dot is nothing but mass flow rate, kg per second, unit of the mass flow rate is kg per second. Cp, specific heat capacity at constant pressure, unit of the specific heat capacity at constant pressure is kilojoule per kg Kelvin. Then delta T, nothing but temperature difference. So, this can be measured with the help of enthalpy values also. So, if you want to measure, if you want to calculate the heat added with the help of enthalpy value, we need to calculate H1, H2 value from the psychrometric chart. How we are going to calculate the enthalpy value from the psychrometric chart? So, point 1, we can draw a inclined line up to specific enthalpy scale. There we can mark 0.1, that will give you the enthalpy H1 at corresponding to 0.1. Similar way, at point 2 we can draw a inclined line up to specific enthalpy scale, that will give you your H2 value. Okay. So, difference between these two we can write here, because here H1 value is always lesser than that of H2. Enthalpy is nothing but heat content. While adding heat, temperature is added, but moisture content maintaining constant. So, if you are adding heat, the enthalpy value is increasing. Okay. H2 is always higher than that of H1. So, you can write in the expression m dot is equal to H2 minus H1. Okay. So, what is the unit for heat content is kilowatt. So, whether we are getting the correct unit for heat content, let us check. So, mass flow rate kg per second, the enthalpy value kilojoule per kg. So, kg will get cancelled out. So, kilojoule per second. So, kilojoule per second will give you kilowatts. So, whatever the substitution is correct to obtain the heat added into the sensible heat. Okay. Okay. Now, in this class we have seen about sensible heating. We are injecting some amount of air and heating the air by increasing the temperature without increasing the moisture content. This is the main objective of the sensible heating. This is very useful for psychrometric processes. Thank you.